Hi everyone, so I'm going to be going over another projectile motion problem. This one is a bullet is fired from a gun that has an upward component of 49 meters per second and a horizontal component of 60 meters per second. What is the maximum height the bullet reaches and how far forward does it go? So let's start by drawing a quick diagram. So if we have the gun right here, something like that, and then the bullet is shot, and then so it travels something sort of like that as a projectile. Okay, so the first question is, what is the maximum height does the bullet reach? So the maximum height is going to be right up here. And if you remember, the highest point is where your velocity is equal to 0. Okay, so this is just a purely kinematics question. So let's go ahead and maybe just list out what we do know. So we know that the final velocity, we want it to be equal to 0. The initial velocity is given, which is 49 meters per second. So remember, we want the y component. And we know acceleration, of course, is equal to negative 9.8 meters per second squared. And what we don't know, or what we're trying to find, is the distance. So since you're trying to find distance, you want to look for formulas that have distance in them. So this includes d is equal to VIT plus 1/2 AT squared, and also this one, VF squared is equal to VI squared plus 2AD. So the first one isn't very good to use because we don't know time, but we do have the others. But then this one looks like what we want to use. So because we have both VF, VI, and acceleration. So what we could do is actually just solve for distance and then plug in the values and we'll get our value. So we get, so if we have VF squared, we just want to minus VI squared from it. So we get that over 2AD, and we're just going to divide both sides by 2A, and then what we get is distance is equal to VF squared minus VI squared all over 2A. And now we just need to plug in the value. So what you get is 0 minus 49 meters per second squared all over 2 times negative 9.8 meters per second squared. Okay, and if I calculate that, I get 122.5 meters is the total height in the y direction. So the next question is asking how far forward does it go, and to assume that it's at a level surface. So what we want to do is find this range over here. So we can just use the range formula for this. So r is equal to v squared sine 2 theta all over g. So note that there's two things that we don't know. We don't know the total velocity and we don't know theta. But those are easily found because we are given the components of the velocity. So we're given Vx, which is equal to 60 meters per second, and we're given Vy, which is equal to 49 meters per second. So it's easy enough to just grab this value here. So that's just going to be V squared is going to be equal to Vx squared plus Vy squared. And to get that, we just need a square root. So we get Vx squared plus Vy squared, which is going to be 60 squared plus 49 squared, which is going to get you 77.46 meters per second. Write that in, 77.46. And the angle also we don't know. Right, theta. So that's, once again, we're just going to do opposite, which is Vy over adjacent, but we could use any of the trig formulas. Let's just use the ones that are given. So you get theta is going to be equal to the tan inverse of Vy over Vx, which is equal to tan minus 1 over 49 over 60. That gets you 39.2 degrees. Put that in here. Okay, so now we have all the values we need to solve for our range. So let's just go ahead and plug those in. So V was equal to 77.46 squared plus sine 2 times 39.2 all over 9.8. And I get 599.7 meters is our range. That is the final answer. All right, thank you so much for watching. I hope this helped. If you have any questions or would like me to do any other physics problems, please leave them in the comments below. Thank you.